So hi everyone, we'll be starting now. Welcome to the Inclusive Space Seminar Series at the Bartlett, the Faculty of the Built Environment here at UCL. So today you have joined the January edition of Inclusive Spaces. My name is Provides, currently lecturing and teaching for contextual theory at the Bartlett BPro program.
I'm Alberto Fernandez as well. I'm a professor of architecture at the University of Chile. I'm a tutor in several programs in the Bartlett School of Architecture as well. And
Hi, everyone. I'm David. I'm also a technical tutor at the Bartlett and a computational designer at our. And this session will be recorded and added to the faculty's YouTube channel, Bartlett EDI website, and forwarded to registered attendees. We encourage you all to submit a question for us, the speakers, at any points during this lecture by clicking on the Q&A function on the bottom of your screen. You can also submit your own questions or upload others. We will hear the presentation for the first half of the session and begin the Q&A in the second half before ending at 2 p.m.
yes, well, this roundtable on decentralizing solar economy will give insights on how civilization can be redefined in the face of our energy crisis and the potential of solar energy development in compensating our most urban capacities in renewable energy, for sure.
Yeah, so the three of us is a research collective called REAR, short for Rational Energy Architects. We usually do things as a team, and we have, perfect deck of slides and pre-rehearsed scripts and so on. But in the spirit of the Bartlett Inclusive Space, we thought we would show you how our internal meetings and brainstorming sections as a research collective usually look like. And we want to include you in our conversation. So David and Berto and I will each give a brief provocation of the core ideas, show some examples of what the output can look like, and then we will enter into an interactive roundtable to discuss their convergence and some of the challenges we may anticipate when implementing the core concepts. So let me share my screen. Cool. So first, the core concept that we have for renewable urban futures stands at the intersection of four core ideas: solar economy, decentralization, participatory design, and artificial intelligence. But first, what is a solar economy? Or maybe a better question to ask is, what would be a solar economy? So an economy is basically a set of processes that involves value exchange and transaction. So a solar economy would be the production, distribution, and consumption based on solar resources as transactional units. So what can it actually look like? Well, I propose to start with some science fiction based on theoretical physics, not only because it's fun, but it also helps us to imagine alternative futures, and we design through speculation. So in 1964, the Soviet astronomer Nikolai Kardashev was thinking about the problem of how we can measure and rationalize energy consumption on a cosmic scale. So although the scale is entirely hypothetical, it is not only useful in helping us to understand how civilized we are as a species in terms of energy usage, but also to imagine how we may design our technologies and innovate towards a more sustainable future. So the invention of scales in general is a sort of a limit set to a certain problem so that we won't be venturing into scientific experiments that may never work out in human lifetimes, or that it will actually take more resources to invent something than the problem itself will consume. So it also sets some metrics on how we can measure and evaluate ourselves as a species. Now, if you actually take a look at the scale, it's very simple. 3 types of civilization. A type 3 would be able to control energy at the scale of its entire host galaxy. A type 2 civilization would theoretically be able to control all the energy from its host stars. So how can we imagine this be implemented? Well, one of the ways to do this theoretically is the Dyson star. Some of you might have seen this in Star Trek. It was proposed by the famous physicist Freeman Dyson, who sadly passed away last year. What it does is that it covers the entire sun in the solar system with photovoltaic element, such as that of solar panels or other things that can absorb light and turn all of that into electricity, basically harvesting free energy in a very centralized manner. So let's look at Star Trek.
In the 20th century, a physicist called Freeman Dyson postulated the theory that an enormous hollow sphere could be constructed around a star. This would have the advantage of harnessing all the radiant energy of that star, and any population living on the interior surface would have virtually inexhaustible sources of power. Are you saying you think there are people living in there?
Possibly a great number of people, Commander. The interior surface area of a sphere this size is the equivalent of more than 250 million Class M planets.
Sir.
So basically what they're saying that because they were able to detect infrared signals at the same frequency as pulses from a star, but then they were not able to see the star in visible light spectrum. So that's how they knew that they had encountered a highly civilized species in space in terms of energy detection. And you can see that the scale to such intervention is so huge that it basically implies a very centralized system in light harvesting. And we know that we're pretty far from that as a civilization. Whereas a type 1 civilization would theoretically be able to control all of the energy from its host planet. For instance, you may have seen the Death Star from Star Wars, which harvests all of the energy from one planet, but afterwards the planet would die. So that's not very ideal for us. Or more realistically, we can have large-scale application of fusion power. Some scientists are investigating this. Our sun keeps burning for billions of years on fusion power. So they call this artificial sun. So as opposed to splitting atoms and release energy from its chemical bonds, they basically put atomic elements together so that it can keep burning forever. Alternatively, we can harvest large scale of antimatter in our universe. But then if we want to imagine a situation closer to us, then obviously we have to at least cover the entire surface of our host planet with renewable harvester, such as these familiar devices that we know indirectly through wind or hydropower or with solar panels. But one thing to note that is by now we should have realized we, human as a species, can barely be considered as civilized in the lands of energy. So although there are technical challenges to achieving this, for instance, we don't know how we can basically reach type 1 on the scale without completely covering the surface of a planet with human-made structures. But perhaps one of the more urgent questions to ask here is not a technical one, but a social economic one. So how do we actually incentivize all of the individuals in all of the nations and all of the continents to collaborate, and how we can begin to make that transition? So this is where inclusivity comes in, because it takes everybody to do it in order to act at a planetary scale. This is also where some people will say that, well, we're basically hopeless because we can never achieve consensus, so we might never fight back climate change. But actually, we don't need consensus to do it. And we'll come back to this question later. But before that, I want to dive deeper into inclusivity. And when I say being inclusive, it doesn't mean that we're just inclusive to people, but we should also be inclusive to systems and processes. And we would need both centralized and distributed approach to work together. So this is the definition of decentralization, which is when there are centrality, but then centrality is distributed across a certain network. So we as architects and planners, we concern ourselves with how we can design not just energy efficient buildings and solar devices, but also decentralization and incentive frameworks so that more people will participate and are willing to participate and they can participate. Now, if we look at some centrally proficient but decentralized approaches, such as that in Hong Kong, the government pushed out fit-in tariff programs where private sectors and individual households would put solar panels on their roof and sell the generated energy back to the public sector. So this is what is called a distributed power generation that is operated through a financial subsidy. Because it involves rapid energy transaction between multiple entities, this creates an economy of solar that is decentralized. So this all sounds very perspective, but what are the challenges for scalability and why aren't we seeing it implemented everywhere? On a technical level, the more solar panels you put together in a series, the larger the electricity resistance will cause energy to dissipate. So that's not very ideal. And on an economic level, the market entry cost for implementing these devices individually is really high. So not everyone can afford it unless the fabrication cost comes down. It would also require economic provision at startup point, such as mortgages by bank that is supported by policy framework. So alternatively, we can design devices that are more portable and mobile so we can break down the cost for individuals, but then it has to look a lot more fashionable than this, right? On a social level, if the sun is ever changing, and if every city has a different spatial quality, if everyone has a different lifestyle, why should all of our solar panels look the same? Can we design strategies that are more personalized to our behavioral patterns so that it incentivizes solar adoption socially? Now, if we go back to our cyberpunk examples, the Death Star, the Dyson Sphere, none of them are really flat and boring when it comes to harvesting energy, right? So although we're not living in a sci-fi, this has prompted a critical rethink in how diversity is indeed one of the keys in being energy civilized. So there are emerging smart materials that actually facilitate diversity on a technical level, but the question goes beyond this. How can we be solarly and socio-economically diverse so as to be inclusive? Well, in answering this question, we realize that we must not look too far, but to look at our own terrestrial and aquatic biology, which already covers the entire Earth with distributed light harvesting capacities. And surprisingly, all of nature together is more civilized in terms of survival than the human species alone. So that is why decentralization is important, because it takes all of the variety and diversity in order to be civilized. And this is a consensual problem. But if we think about trees and forests, they do not have to agree with each other on everything in order to survive, right? They have this hybrid strategy of competing and collaborating so as to adapt, and Darwin have taught us about natural selection. This basically provided a model for us to learn from. And nature has developed a myriad of strategies to harness energy from the sun. For instance, vegetation in rainforests evolves into dense canopies, whereas cactus in desert develop spines to minimize surface area. So all these can be biological model that we can design our solar devices towards. And each species develop their own unique topological solution to the same problem of light harvesting. So life on Earth is already doing it, and we actually have hope that we might be able to imitate them. And if we are to imitate nature, we're basically venturing into fields called biodesign. So from here, we can already get a sense of the scale of the problem at hand. The amount of data from natural to social which has to be comprehended is beyond the human capacity. So this is why at REAR, we propose that we must collaborate with our machines and across disciplinary and territorial borders so as to design towards this future. And this is actually one of the projects developed by our students. As architects, we're learning to work with algorithms, particularly with artificial intelligence, so then we can learn from large amounts of data and devices solution inductively. At the same time, if we wish to personalize both devices and our social economic strategy, the fastest way is not to control design only in the hands of a few, but invite a larger set of actors to contribute what they think, what we call participatory design, which David will speak a bit more about.
Thank you, Brooke. Just a second, just start sharing. Okay. So now I want to discuss with you all a little bit about approaches to how we can use artificial intelligence in a way that can encourage and help participation in design and the use of spaces and before design in all of the touch points that we might have and when we are discussing a project. So I want to share some thoughts and some examples on how this could happen. So first of all, the definition. When we're talking about artificial intelligence, we're essentially talking about a scientific field that studies and tries to create digital algorithms to solve problems that are often associated with intellectual labor. In other words, we're trying to automate tasks that are related to intellectual labor. So these are not always necessarily accomplished by imitating human behavior, but the deployment of AI is based on machine learning algorithms. And these algorithms are done around the will to artificially reason or understand complex questions and produce specific results. Okay, that's cool. So now, when we're thinking about participation and we're thinking about automating intellectual labor, we can also think about software that enables participatory design as one of the approaches that is possible when we start discussing these topics. And actually, this is not something really new. In the 70s, we had Cedric Price developing the Generator project together with John and Julia Fraser. And the generator was a project that was a dream of an interactive architecture. And it was put together by Price and the Frieders in the form of a design project, but also as software and hardware. And in a way that these software and hardware technology could be used to enable this generator to reconfigure. So you have spaces that could be reconfigured. And the way that they put it is that the generator automates the process of understanding intent and translating that into reconfiguration. In other words, it is automating an intellectual process, right? Design and understanding how to reconfigure a shape is an intellectual process. So we were already talking about some artificial intelligence here. And also in the mid-20th century, you had Yonah Friedman. Yonah Friedman was the architect behind the Villa Spaziale, which was this huge, average sprawling urban architecture structure that was made of these modules that people could inhabit and as their housing, as their workspaces, as any other to fulfill any other necessities that they might have in this space. And what it is important about this project, or what we are discussing, is that Yonah Friedman was also discussing ways to enable people to design their own spaces. In other words, replacing the architect and enabling the future users or inhabitants to design their own spaces and facilitate that in the way that he, in the early 60s, 70s, the way that he decided that could be approached was through software. And he designed the flat writer, flat as in apartment flat, as a piece of software that was designed to enable people to design their own apartments, to design their own flats and their own spaces. And if we jump a little bit further in time, we can see projects that are using current technology and drawing from these same ideas. So you have Nathan Peters' Yonah, for instance, that uses machine learning, specifically a pixel-to-pixel algorithm to translate data. So you get like one type of input, you get another output out of it, simply as basic as that. And by coupling up a series of translations like that, so from a boundary to a program, from a program to a floor plan, from a floor plan to 3D, he was seeking to enable, as the name says, enabling alternative architectures. He was seeking to enable users to develop, to design their own living spaces. So, and this is one approach, right? How can we use artificial intelligence or software to enable participation? But also, we can think about design as something that is participation driven. And also, we think about participation in the post-build, especially when we were talking about automations. And to talk a little bit about that, I want to bring up this project. This project called Public Parks that had, the idea behind the project is this, again, ever-sprawling possible space that is organized by these Black components. And in between these Black components, you have light, you have spaces that people can inhabit. And the idea behind the project is that you have a software that reconfigures these parts, evaluates based on feedback from people. So we need to reconfigure this space. And one of the basic necessities for how the space is reconfigured based on evaluation is to understand from a computer standpoint, what is the spacing here? And as humans, we can look at this image and we can think like, okay, this image, all of these red rectangles are spaces. That's really easy to understand, but it's not for a computer, for an algorithm. And if we want to have this happening in the real world with people using the space and modifying this structure, giving their feedback, the computer needs to understand the way that people understand the space. And in order to do that, just going back a little bit, That is an intellectual process, right? Understanding, looking at an image and recognizing patterns, recognizing spaces in there. We needed the computer to do the same. So in order to achieve it, we thought of this machine learning application algorithm called Pix2Pix again, that basically translates one image to the other. So it would get an image that is like this one on the top right, that you have the components in space, and then you have these elements being translated into separations of spaces so that the computer could understand them. But in order to do so, we needed to produce a data set that showed the algorithm how people understand space, right? And this process needed to be collectively produced in order to generate a training set and a number of images that the algorithm could use to learn in a way that it would represent a collective understanding of what a space is in that setup. So here, participation is fundamental in order to create a setup that can later be implemented in real life in the reconfiguring of the space. And again, this process illustrates a way that we can use artificial intelligence to participate together, but now in the end line of the design process, right, in the built environment. And also we can think about a participation-driven automation to software-enabled participation, right? Now, how can we think about both of the processes? How can we think about we can enable use participation as a tool for automating these complex design processes, and also use this process that we automate to facilitate participation. So an example of that is this other project that is called Gesture. This project uses a similar algorithm to the previous one, in which you have images that people draw on. But this one is looking to automate the process of capturing how people draw shapes and connect shapes. So you have a first level of participation in which you have people drawing on images, creating this data set, and then this later gets put on this algorithm that consumes this, and you packages it up in a way that is super simple and automated, and so that it can be shared with people who do not share the same expertise to design something like this tower, and really quickly just draw a line and have an output that relates to that. So you have participation on one level, enabling the creation of these data sets, and then participation made possible on another level when you can use this tool that is automated, really lightweight, to enable people with no that have no specific training to achieve the same level of output. So in conclusion, just to wrap up all of these ideas that I was trying to throw at you all, I want to talk just briefly about how we use this in our research. How the three of us, together with our other partners, how we use this in our research. So we are constantly investigating a pipeline, the creation of the pipeline that takes really complex inputs such as designer intent, location, solar analysis, computational aggregation of components. This pipeline that is really, really complex and really heavyweight in terms of design and in terms of computation, we want to package it up in another pipeline, in a meta pipeline that automates this whole process using artificial intelligence. So we use a similar approach. Have a from the complex pipeline, we generate inputs and outputs for a training set that an artificial intelligence later consumes and makes sense out of it, so that it can become so the objective is to reach a lightweight process that consolidates both the designer and the computer expertise into a model that is capable, a process that is capable to be shared with a larger audience, right? With people who do not have the computer or the expertise to do so. And it makes possible new opportunities for participation too. And yeah, that's it for me.
Okay, perfect. So my turn, the third provocation in this afternoon. So I'm going to share my screen. Now, here we go. Okay, so well, from my perspective, in this provocation, it's about this idea of how it's possible to get or capture energy around the globe in different scales. So I have a few interesting questions and information that is coming to be part of our discussion later. So firstly, I have here a solar energy global map, asking us something about do we have enough energy in the world? Because usually we are dealing with this idea of a lack of electricity, a lack of energy. We need to optimize the use of our resources in different ways. But well, this is the interesting and uncomfortable truth sometimes. In this map here, we have the global horizontal irradiance, which is the measure of the density of solar resources available per horizontal surface area in the globe. And I'm telling about that because in this graph, you can visualize two interesting aspects. Firstly, that almost always it's possible to get some level of radiation in terms of kilowatts hour per square meter in the globe. Doesn't matter if you are closer or not to the equator, but for sure we have different degrees of amount of energy that are possible to be captured and transformed in electricity or in energy. Yes, for sure. So, for instance, in this graph, we can see that in a zoom by year. If we are summarizing all the kilowatts per year, we can see that even in several areas in the globe, we have more than 2,700 kilowatts hour. So which is a lot in terms of average. Thinking that usually, well, some data is coming later. If for a household here in UK, we are using more than slightly more than 3,000, but for a household. So it's not just per person. It's something that I want to prove you later. So in terms of direct normal irradiance, is as well is the amount of solar radiation received per unit area by a surface that is always held perpendicular or to the normal to the solar radiation or solar rays. In that sense, this graph is even more powerful because we have, if we are using this idea, this concept, and we can capture even more radiation per square meter. So we have here in the best scenarios more than 3,600 per square meter. And with the average near to 2,100 in the globe. So, but what means exactly in terms of what we are doing in our cities, in our countries? So here I have another example about the UK, because well, here we are based in here in the bullet. But we have the UK is not for sure is not the most powerful land if you want to measure it in terms of kilowatts per hour in comparison with the globe, for sure. But still here we have a decent average between 800 and 900 per kilowatts hour per year in square meters. But even more interesting, in here I'm showing you the average, and as well I'm getting the total land surface in UK, which is this 242 million meters, and multiplying this, it's a kind of super simple exercise. We have this huge amount of kilowatts watts year in the UK. So more than 230,000 millions, which is a lot. So dividing this in the amount of population, which is a nice exercise as well, because I want to prove you that we have enough energy per person in the globe, and we're using UK and another country as a starting point for this conversation. So in that sense, dividing the total amount of available energy here in terms of horizontal surface, as well divided by the amount of population, which is over 67 millions inhabitants, we have a number of 3,423 kilowatts years per person. If we want to use every single square meter available in the UK. And the most surprising part is this one, because in terms of the energy use in households, in terms of kilowatts hour, understanding well, based on electricity, and as we have a 3,731 kilowatts hour on average from each household here in UK. Understand that a household is composed by 2.4 persons. So in that sense, we can understand that here the use of a kilowatts hour per person is 1,426 average, which is closer to 2.5 times less than than the necessities that we still will have. So we can say that we have enough energy in UK. Even in UK, if we are using in the right way the available radiation in a whole year. So what about South America, for instance, and Chile, from my country? And here the situation is even more, let's say, positive, because well, here the average in South America is over 2,000, and well, it's over 2,100, which is a lot. And in terms of my country, is even higher, with peaks of 3,800 in the north, which is huge. It's a huge amount of energy, as well with an average near to 2,200 and 2,600, which is a lot. So it's in that sense, I'm more I have here with the possibility to catch more than twice of energy from using the same amount of square meters. So the same exercise again. I got the average in terms of kilowatts hour per square meter in Chile, as well the land surface, which is for sure is bigger than here, and this is the total amount of kilowatts hour per year. Is outstanding. Look the numbers. So it's 1 billion and near 2 billion. So it's huge. So well, dividing that in the amount of population, we have a total available of kilowatts per person, which is consistently higher than the UK for sure, which is 100,000 in average, more than the which is more than the covering all the necessities for one single person that I'm going to prove later. So for instance, here, the household using Chile 800 kilowatts hour on average, but a household here is composed by 4 persons instead of 2.4. So in any case, we are here consuming in Chile near to 2,000 kilowatts hour per person, which is we are covering the necessities by far. And this is one of the alternatives to this map. Here I have a few interesting questions, because still, I think we have a lot of energy available in terms of potential in the globe, as well. It's still within an additional energy matrix in our cities, because if we are distributing in terms of inhabitants, in terms of households, I think we have a chance to cover our necessities without necessity of a centralized matrix. Yeah? And as well, which country is richer using this energy potential? So returning here, we can see that maybe sometimes this global map in terms of economy is not so clear in terms of energy potential. And as well, we must rethink the shape of our buildings. And now I have a few examples as provocations, and then I'm going to finish my presentation, and let's start with the discussion for sure. So here I have a few examples that we're running from our workshops and from the previous year. And well, here we are using this idea of cellular automation and optimization using a genetic algorithm, as well as David showed us before. We are mixing these ideas with the AI in order to optimize the process. But at the same time, here, as I mentioned, we are crossing this idea of cellular automation and as well of aggregation in order to create efficient shapes and efficient way of aggregation in order to create provocative structures that at the same time are really achieving a higher level of efficiency in terms of the use of radiation in a passive way as well as an active way. So returning to, for instance, some reference like Michael Batty with these growing simulations using CA and neighborhoods, it's possible to create a different level of architecture and understanding this aggregation system as a potential for our design. So here I have another example coming from my research as well, which is proving that the CA has a clear potential to system that can read what is happening in its environment, as well with the potential to reconfigure solutions at trying to achieve the most efficient possible performance according to the problems that is facing. So, and in this example, the operation map that I generated for Valparaiso city in Chile, and here we can see the rooftops, which are in red, which is, well, try to imagine what means red. So this is the total potential that we are finding in our cities. We have tons of possibilities if we want to reconfigure our built environment. So here I found a site that was underdeveloped in terms of structures. So I ran some maps that were understanding the possibilities of a capture of solar radiation, subdividing the available area in a three-dimensional way, getting these possible outcomes. Then, for sure, it's possible to understand as well how these landscapes and cityscapes are evolving time by time during the year, during the whole day. And with that, we can fit our algorithms in trying to understand that maybe we can create a new kind of architecture using these principles. So here is you can see the evolution of this site as well, crossing three different seasons. Well, after that, well, in this case, I generate a 3D point cloud with using the higher level maps, and as well, I feed the CA system in order to find the efficient possible outcomes coming from here, and then finally, different possible scenarios in terms of densities, and then finally, well, it emerged a kind of a weird or alien shape that in a way emerged from the radiation patterns. And as well, in this sense, it's possible to refeed the city with different public spaces that it can, in this case, where they develop, just trying to understand that maybe we can cover some areas for public space, and then with this structure, it's possible to regenerate green areas, using radiation as an opportunity to reconfigure our designs and with small elements and different relationships. Thank you very much, and let's start with the conversation.
Awesome. Thank you, Alberto and David. Yeah, so we have one question in a chat box from Shumil. A question that he or she would like to discuss is to ask what, according to you, will be impacts of COVID-19 pandemic on the field of planning and construction of inclusive spaces for education, work, daily life, and other targets. Well, maybe I can make a start. I think we have all heard of the argument that the coronavirus has existed long before us. So it's actually an important aspect of our evolution as a species. And a lot of evolutionary biologists have claimed that every time there has been a large natural disaster, such as epidemics, it's actually encoded within our genes. So they call this the junk DNA, because they found out that more than 90% of our DNA are not actually actively function. So the hypothesis is that the junk DNA is actually a database of all the previous evolution, including large-scale death caused by epidemics. But today, we all know that we record information of large-scale events a bit differently. So we don't just encode it in our genes, but also we do it in a digital data format. And what the pandemic did best for us is that through collecting all this data, it reveals pre-existing conditions. So all of the things that you see on television, it's not because of well, partly it's because of the pandemic, but it's also because we were planning poorly, we were designing poorly, and we were collaborating poorly. And this also reveals the demographics that are the most volatile, but not just that, it also includes the spaces, events, organization, and processes that were planned in a most volatile way. So how can we be inclusive while maintaining a distance? Well, that's a tricky question, right? But if we actually look 100 years before to the Spanish flu, the architect Le Corbusier already designed urban planning through functional separation. So ordering of program of cities to produce a hygienic conditions. So then we're not excreting the same place we're eating, right? And 100 years from now, I would argue that we're actually faced with a very different question. So as opposed to separation of programs that brings to social segregation in terms of disaster, we should be able to stay close to our native neighborhood, so not to have cross-contamination across district. So maybe we can imagine 15 minutes or 20-minute city. While maintaining import and export, we should also be able to sustain energy and resources supply to a certain extent within our local urban context. So that brings us back to the distributed power generation, right? So we are doing inclusivity through building up local social economic capacity so that each individual would be self-sufficient in terms of energy. David and Alberto?
Yeah, well, I was just wondering about the pandemic and how we have the chance to reconfigure our architecture and our designs in order to create let's say, healthier spaces. Because before the pandemic, we were trying to achieve this weird way of efficiency in terms of use of square meters. In our flats, for instance, we were compressing everything, every single corner. And then finally, when we faced the pandemic, we realized, oh, this is not healthy at all, because we are spreading the virus in a faster way, just because we have spaces super poorly ventilated, with lack of some radiation, and as well highly dense. So without the possibility to keep a safer social distancing, if we can say, if we can mention that as well. So and so on and so on. So then finally we were having as a result this huge problem with several restrictions, because it wasn't possible to, for instance, to use our universities, or as well, or even our public spaces were not really well designed finally. So now we need to rethink that efficiency is not about the money. It's not just about cost. It's about as well the safer way of in which the city is going to be finally the support of our lives. Now, sadly, we are living in a transition in which sadly, I want to mention this, sadly, the richer guys became richest in the pandemic, and the poor, well, it's obvious, poor. So why this is happening? Because sadly, our society is still working with this idea of a problem as an opportunity of business, instead of thinking in something different, which is the common benefit of everyone. So it doesn't matter if I'm rich, if at the end the society is disappearing. So we must rethink architecture in that way, not as a commodity in terms of economy. Is a different thing. Architecture is a support. Is the support of our lives in the end. So I think in that sense, COVID must change the way in which we must design. We are designing, yeah, because we were designing with a different target. Now we must change the target, and it's up to us. So if we are not starting from our practices, from our schools, this is not going to change at all.
Definitely. David?
No, I agree with what both of you said. And I also think that changed a lot the way, similar to what Rebecca was saying, in the way that we inhabit our own spaces, and the way, and that means that the way that we design spaces for implementation, most of all, will need to change. Anyways, we need to accommodate for work more than ever, and in that sense, like collaborating with what Roberto was saying, studio so great, right? Living and working exactly in the same environment that you're living, that you sleep. This is not so great. But also, I would like to think that it will make things a bit more local and distributed in the future, in terms of planning and in the way that we interact with the city. In a sense that since we can work from home, and the working from home became like the new, not the new standard, but a possibility more feasible than ever. I would like to think that this would enable communities to start thriving again, and we start relying on big companies, on centralized locations to provide everything that we needed, and have a way. This is more like a dream than anything, but having a way that the transactions and interactions between small businesses, individuals, small communities can engage in a way that is more beneficial to themselves, rather than some rich guy in the Silicon Valley.
Yeah. So we have a lot of questions coming in. I thought we can each take one, so then we save time. The first one is from Caroline. Thank you for your question. She's basically asking that when mapping, are you considering other uses of the spatial environment, such as non-humans? And she was also asking if there's a paper she can read that links to evolutionary biology on junk DNA, because she felt that it's incredible to hear, and also how it is relating to our research. That is a great question. Actually, I'd like to show you also a project that we did with our student. So this was specifically designed for a vegetation to grow on the envelope of any skyscraper. So this is definitely for non-human design in the sense that it's trying to optimize the building skin, not for human use, but actually for the a very endangered desertation species. So that's one of the example. And in terms of evolutionary biology, it actually affects more than just natural science. It affects social science. Darwinism, understanding of competition for natural survival, actually sort of prompts the anthropological understanding that we must compete, and all of civilization follows a deterministic cultural evolution as well. But then now we must understand that actually every culture is different, every society is different, and we must not say that certain society are more civilized than others, but actually we should form a collaborative intelligence in co-evaluating ourselves as a coherent species in how we're using energy. So that would be a simple answer to that question. But in terms of how architecture can act as a social economic driver, or even what David was saying, the distribution through technology like blockchain or other distributed database that can help us to collect data on a planetary scale, that will be something that the design discipline has to think about. So a second question, Stefan Horn was asking that if you have started looking into other inputs required for harnessing solar energy, notably metals and space, which competes with ecosystem surface. Oh, that's an awesome question. So there may be points where the cost of these input would limit solar energy capture. David or Alberto, do you want to take this one?
Well,
For this, Alberto,
I think
yeah,
okay, perfect. Yeah. I think I'm trying to answer this question. For sure, we are thinking in our workshop as well, in our professional practice and research about different materials, because as we mentioned in our presentations, we are working with the cells for solar radiation capture in order to create energy. Yes, that's the starting point. But at the same time, as I show in my presentation in particular, this is not this was a research in terms of how to create a structure that can capture radiation in order to protect the soil. So it's a different approach. At the same time, in winter times, this mass is releasing a temperature later in colder times. So it's not always about transform energy in solar radiation into electricity. It's about how to, let's say, capture and then how to transform that in different ways, as temperature, as I mentioned, or a better ventilation system for sure, or improving the local vegetation, as provides showing in the examples coming from one of our participants in the workshops, in previous workshops. So it's really interesting, because our analytical database is evolving time by time. So it's not just about electricity, for sure. It's about a broader sense of production of energy in different ways. So yes, we are thinking on that in a passive way as well active ways.
Yeah, so I think we have time for a question that combines Maria and Sophia's. Basically, yes. One question about consensus, the other is about education, and both is about communication, right? So Sophia was asking, what do you think that algorithms fueled by participation mean for consensus in urban design? And what role do you think consensus plays in urban design and architecture when thinking about the larger climate crisis? Whereas Maria was asking, do you think this influence our place for education and the relationship between professor and students relating to ways of design? So David, if you want to take this one.
Yeah, sure. I want to start with Maria's, and I want to take it from the perspective of someone who teaches computational software architects. And if we're talking about participation, artificial intelligence, participatory design, as we were during the presentation, then I think that it changes radically the way that we design even the software that we use. So I think that if we see it from an approach that we are architects developing the tools that we will use ourselves, we can start thinking that taking the dreams of Cedric Bryce, of Yona Friedman, and taking all of these mid-20th century dreams of interactivity and participation and start creating that and putting that in a real way in our current projects. And I think that changes the way that we share technology between teachers and students.
Mhm.
And now thinking about consensus in urban design, I have to say that I'm someone relatively skeptical on the sense of using technology in this really big context of urban design. I kind of refer to Yona Friedman. He had like this critical mass idea of how can you impact people or a community with a piece of software, with the technology or design and participation specifically. So yeah, I would have to say that I'm a bit skeptical in terms of reaching consensus using essentially algorithms that harvest data instead of collecting specific opinions from people in a given context. So yeah, big data, I would say, and AI not really the way to go, but distributing choices and opinion collecting, that is more of his effective way to go about the problem, I would say.
Yeah,
Yes.
I agree. Yeah.
Well, we have just 1 minute for
Yeah.
say-
I mean, I think David's point is that AI currently is still simply inductively trained, but
Mm.
human intelligence are a lot more diverse. We can be deductively trained, we can be abductively trained, and many other ways that we cannot measure. So AI is a
Yeah.
tool, but then we are the designers, so we should learn
Yeah.
to work with them as well.
I want to add a little something. I think it's better to think this in terms of negotiation, local negotiations, because it's the negotiation is a process in which you are giving something and you are receiving something in exchange something. So it's better that consensus. Maybe you have something like, okay, let's try to find the best for all of us in local relationships, and then that is going to scale in a systematic way in a global one. So it's a part of the von Neumann as well way of thinking.
Yeah. So thank you, everybody. This session would not have been possible without your participation, and we're really thankful for your question that prompts a very critical rethink on the subject. So thank you for joining us today. Inclusive Space will be back on Wednesday, 22nd February with visibility, inclusivity, and allyship in built environment professions. So sign up details are in the chat. We hope to see you then. Thank you so much, and bye-bye.
Thank you so much.
Thank you,
Take care.
everyone. Bye.
Bye.